Greetings, one and all. Great day for a webinar. Hope you're well. Thank you, everyone, for dialing in. And I'll give people a bit of a chance to come through the virtual turnstiles, but just a few notes before we kick off. So this is the number 7 of the Stormwater Fundamentals series. So thanks for everyone who's dialed in already to the previous ones, and thanks for the presenters as well. So Mukta, Murray, and Sean for delivering some stellar sessions, and we're going to have Ian Adams actually next week as well. So sorry, next month. Getting ahead of myself. But if you haven't already registered for some of these, feel free to jump onto the website now or whenever suits, or subscribe to our newsletter where we give them a bit of a plug each time. Speaking of plugs, a shameless plug for an event that's actually happening. Gee whiz, that's not long away at all. Bioretention Unfiltered, Western Sydney. It's got some great speakers. Again, if you're keen to register, just jump on the oceanprotect.com.au events website. But we've got off the top of my head, I can think of Mark Liebman's presenting, Craig Bush from Sydney Water, Mari Powell from Optimal, Kafeng from University of New South Wales, Nicole Walwood from Water New South Wales. A whole bunch of cool kids talking all about bioretention. And I reckon if you're dialing into this webinar today, you're probably you're a bit of a fan, which is great. But if you're keen to find out more and maybe register, jump onto that website just there in the bottom right corner. Also, if you're a fan of the podcast, we've got some cracking episodes recently released a couple of days ago, talking about the South Australian harmful algal bloom. And if you aren't familiar with that, I really think this isn't getting nearly enough media attention. And we were privileged to have Dr. Scott Bennett join in to talk about it, give his insights from a week diving underwater around that impacted area. Long story short, it's pretty gruesome. Just a reminder, folks, if you're in Queensland, we've actually moved. So our office has moved from Loganholme to Stapleton. It's basically given us the ability to make precast concrete, such as our UrbanPond structures. And you can see a few of them getting installed very recently. So if you're keen to find out more about UrbanPond or whatever, just jump on that link there. And just a reminder before we dive into the official proceedings, if you have any questions that you'd like to ask me today, please put them in the Q&A, and the slides and the recording will be made available on the oceanprotect.com.au/webinars. Generally give us a couple of days to have that up. And also if you're after a CPD form, please, you probably already have actually asked for one as part of your registration process, but if it doesn't come through within a week or so, please email us at marketing@oceanprotect.com.au. Cool. So we might dive into the official proceedings if you like, and just like to acknowledge two things. Number one, traditional custodians of the land. So I'm in Brisbane, so that's the Turrbal and Yagara traditional owners of the land on which I'm speaking of today. But also a second acknowledgement I'd like to make is that I have a major conflict of interest here. So I work for Ocean Protect, and we obviously sell or install and design and maintain Filterra Bioretention, which is high flow bioretention. And obviously most of the drawings and case studies I'll show you today are actually of Filterra bioretention systems. So again, I've got a conflict of interest. I'll try to be as transparent with some of the resources and references I use. Obviously the photos are pretty straightforward. Nothing's been photoshopped. But if you're keen to dig more into the detail, check out some of the references, please do so. So first up, we're going to just run through some just real fundamentals, and then I'm just going to show you a whole bunch of real world projects, basically, which I think really illustrate some of these key fundamentals of what high flow bioretention actually is and how does it work. So first up, what actually is it? So if you've used or are familiar with conventional bioretention systems before, very, very similar, but they are smaller. So generally they're about 3 to 5 times smaller than conventional bioretention systems. And there's a couple of key reasons for that, but also there's a couple of key differences between Filterra or high flow bioretention and conventional bio. First up, so this is just a conceptual diagram. So this shows on the left a conceptual cutout of a Filterra, what we call bioscape or biobasin, and on the right it's a tree pit system. So a couple of key things to get from the get-go. So number one, how are these systems so much smaller? The key reason is the filter media. So instead of using standalone filter media that you'd see in a conventional bioretention system, which might drain at say 200 millimeters an hour, we use what we call Filterra. Now that's made by Ocean Protect. It is the only proprietary component of high flow bioretention or Filterra, but that fundamentally drains quicker. So instead of draining like 200 millimeters an hour, Filterra drains at 3.5 to 4.5 meters an hour. So because it can drain quicker, we can make these systems smaller. But even though it does drain quicker, it still achieves, and the results will show this in a sec, it still achieves really, really high rates of pollution removal. Another key difference is we use a surface layer of mulch. So that's generally, you can see it on the diagram here and also here. It's a 75 millimeter depth of what we call double shredded hardwood mulch. It's hardwood mulch that's gone through a shredder twice. It's quite a, I guess, specific mulch type, but it is readily available from landscape suppliers, and I've even seen it in Bunnings. The key reason why we use that is for two reasons. Number one, it acts like a GPT, like a pre-treatment measure to help remove silts and fines and solids that can otherwise block or blind the filter media. And this is something I reckon conventional bio should be doing, as well as applying a suitable mulch if they don't already. The second thing a mulch does is like mulch on your garden bed. It helps to retain moisture within the filter media, and obviously it helps plants grow. Can leach a few little organics to help replenish the filter media, but fundamentally it's just like mulch on your garden bed. We do recommend replacing that mulch roughly every year or so. We always recommend it, but I'll show you some examples that unfortunately doesn't happen too often. But having said that, the systems still maintain their resilience and function even in the lack of really any significant maintenance at all. Another difference is we don't need a transition layer, like a sand layer between the filter media and the gravel. It's basically filter media straight into the gravel, and we obviously manage the particle size distribution, make sure there's nothing being lost there. Another difference for the bioscape systems is that all our systems are offline. So we don't allow high flows that can otherwise cause scour and erosion to enter the system. Instead, we basically have some sort of structure that basically forces low flows or small and frequent flows into the bioretention system, and high flows basically bypass. So any risk of scour and erosion is avoided, but also it means when we construct them, we can basically keep them offline whilst the upstream catchment is being worked on and stabilised. And that's really handy. And I'll show you some examples of that in a sec. But yeah, key difference is fundamentally they're just smaller, 3 to 5 times smaller in general. In terms of the application, basically wherever you put conventional bioretention systems is more or less a suitable site for Filterra bioretention. And there's just some examples here, and I'll show you some more in a sec. Configuration, like I said, there's the tree pit systems, the bioscapes. We also occasionally do a sort of raised box as well. In terms of performance, there's a lot of data that shows that they work. So it's not just one study that's been cherry picked or anything like that. There's 7 real world published studies of Filterra bioretention systems treating stormwater like real world events. And all those references are in the report on the right, which is publicly available. That's on the Filterra website. The data has also been peer reviewed by 3 separate groups. So Damon McCann, Ralph Leiterer, and also SQUIDEP approval. So fundamentally, Filterra has been SQUIDEP verified as well. Again, the peer review reports and the SQUIDEP certification and the SQUIDEP review paper are all available in that document on the right-hand side there as well. So fundamentally, most councils across Australia allow their use, at least on private sites, and several allow them to be used on public sites as well. In terms of maintenance, it's really quite simple. In fact, I'd say it's actually easier to maintain than conventional bio. And again, I'm biased, but firstly, they're smaller. So the work area is 3 to 5 times smaller. They're generally easy to access, but you don't need any specialized equipment or Ocean Protect involvement to maintain these assets. They can be done by any suitably qualified people. But the key maintenance activities is basically just giving the mulch a replacement Again, we recommend that every 6 to 18 months, but again, it rarely happens that frequently, at least. And giving the giving the vegetation a bit of a haircut as well. And I'll show you some examples of what that looks like in a sec. Obviously, I don't know anything about haircuts. If you need the back of my head as an example. But in terms of case studies, there's a lot of them now, and it's a lot of them in Australia, over 200. But it's worthwhile noting this isn't new technology. Ocean Protect have been doing it in Australia for about 6 or 7 years, but in the States they've been doing it for about 15, 20 years. And there's a lot of systems in the States. And I'll show one in the end, actually. How to specify, it's very simple. Generally, Ocean Protect, just get a blob on a page or something like that. We can do all the modeling for you, design drawings, no obligation. And we've, as part of the sort of any sort of system, if any clients are on the call, and I can see a couple, greetings, you'll know that basically we can do the detailed design drawings and the music modeling, all for no cost. So that's a crash course in what Filterra is, but I always like the proof is in the pudding. And I just far prefer showing real world examples to give you guys a better feel for, I guess, what these systems look like and how they look and function. So I'm going to start with the older systems first. So Warwick Farm, these are out of Western Sydney. These are at the first installed in Australia. Installed, what's that? Nearly 8 years ago now. Wow. Okay, so this is there's two of them, 120 and 140 square meters. This first one, I show the drawing here just to give you an idea of kind of what at least the first ones looked like. So this is a said 4-bay in here. Water comes through. The green lines you can see are the bubble up flow distributions, and the red lines are the under drainage. That's an overflow pit there. And there's a bit of a dividing wall as well. But this fundamentally, we inherited a concrete pit. Not our preferred choice, but in terms of the depth of the pit, but certainly that's what we were tasked with installing. But fundamentally, this is what it looked like on day one. So just some highlighting some key features. Again, bubble ups, clean out points for the under drainage overflow pit. It's worth noting that whilst I show bubble ups, which is a really common, probably the most common form of flow distribution, there is a trough or channel arrangement, which I know I'll show some examples of that in a sec. But yeah, this is basically day one. Planted out, what's that, 2018, January 2018. So a couple of years later, these plants have just grown and grown and grown. And this is what it looks like very recently. So generally, I might zoom back because you can't actually see into it anymore in terms of because of the plant density. But generally, we prefer a combination of small plants like grasses and trees. And generally, the planting density is lower than conventional bio as well. So you can see here, if I backtrack, the planting density, generally, we don't go more than about 1 plant per 4 square meters. And there's a bunch of reasons for that. But number one is we have very little plant die-off in our systems. Number two, we like to give the plants room to spread out and grow. And number three, we want to get in there and actually, or at least have the ability to remove the mulch and put new mulch down. Having said that, I don't believe this one's actually had any maintenance for several years. But again, you can see the plant growth. It's pretty high. So plants are living their best life. This is the second system out there. Again, concrete sort of box that it was installed. Doesn't have to be that way. I'll show you some examples of some battered slopes in a sec, but that's it day one, and that's it a few years later. This one has actually been hammered, not from stormwater, but floodwater. This is right next door to the Georges River, and which overtopped in a flood event and deposited about 1 foot of mud across the entire mulch. But all in terms of the maintenance intervention was really just removing the mud, removing the mulch. We did a hydraulic conductivity test and show that the system was draining still really, really well. So it highlights to me the importance of that mulch layer to help protect the system and maintain system longevity. And again, some of these trees are just pretty impressive. But yeah, it hasn't really, I don't think it's got any maintenance apart from that flood recovery. Kingswood, this is a system that's been in the ground for over 7 years now. This is one we've done a whole bunch of performance monitoring. We've monitored this for 7 years now. This is one we submitted for SQIP approval. It's been study results published in the journals, etc. But fundamentally, this is kind of what it looked like when we were installing it. That is the Filterra bioretention system. So there's a little cutout in the curb there. You can see water just basically drains into it, just like a streetscape bioretention system. In that cabinet, there's a whole bunch of fancy monitoring equipment. But in terms of maintenance, and this, I like showing these photos because it shows you what maintenance looks like. So yeah, when we remove the mulch, the key reason we do that is because that mulch will capture a lot of silts and fines that can otherwise block the filter media. And we also just want it to be, that obviously has a whole bunch of pollution, which, ideally we don't want just sitting in there forever. So ideally we remove that mulch and place new mulch down. You can see here the tree has got a bit of a haircut as well. But just give you an idea of, I guess, a small scale maintenance intervention. And that's still going gangbusters. I think we're still monitoring that 7 years down the track. These are some of our bigger systems, and these probably are getting more and more common. These were installed, 5 years ago? Design drawings, again, done by Ocean Protect. You can see some of the features here. This is this 500 square meter system. You can see that this is a bioscape separated into individual cells, generally less than about 9 square meters. The red lines show the bubble up flow distribution points. This is a coarse sediment forebay to help mitigate sediment loads. This is actually this little channel here, the high flow bypass as well. But just to give you some photos of what they look like day one. So this is day one installed. So overflow pits, you can see the bubble ups, dividing walls, etc., flush points, the mulch, plants, and over time, and keep in mind, this was originally specified as a conventional bioretention, 5 times bigger than what the Filterra ended up being. And the developer went with Filterra because it meant he didn't actually had to cut down a whole bunch of adjacent bushland as well. But over time, this system's just grown and grown and grown and grown. You can see the bushland over here that was basically stopped from being cut down because the Filterra was so much smaller. You can see here just some of the features: bubble up points, overflow pits. This is the high flow bypass. And this also shows the plant density. So we planted 1 plant per 4 square meters on this system. So conventional bio, you're often looking at 6 to 8 plants per square meter. We're looking at 1 plant per 4 square meters. So the density is substantially lower. So you only appreciate that if you get an aerial photo, but if you actually look into just from the side, you can see the planting density is actually probably, visually really still quite dense. So again, the plants have had very little die-off, I'd say almost zero. In fact, some of these plants are actually self-seeded. That tree we didn't plant, that's just come in from, I don't know, a bird dropping a seed somewhere. But you can see what 1 plant per 4 square meters looks like. It basically gives the plants plenty of room to spread out, but equally, if we wanted to get in there or someone wanted to get in there and replace the mulch, they could. This one is, and I know Alan West from Kingston Council, I saw you dial in before. Greetings, Alan. Alan's the champion of this project. Kudos to Alan for trying something new, because I know Filterra is a new thing in Victoria. But he obviously heard about Filterra, and long story short, there was a conventional bioretention system that had been installed that just essentially wasn't operating as well as Kingston Council would have liked. It was only been recently installed. I think it was installed 2017, but a few years later was really struggling with some operational issues. So Alan and Kingston City Council took the initiative of trialing a Filterra bioretention system. So we basically took the 170 square meter conventional bio and just used a portion of that, about a third, 51 square meters, and took the 51 square meters and made that the Filterra, and the rest was just landscaped. So this gives you an idea of just the construction of this is kind of what we do. So as part of any sort of system, we get in there and actually design it and install it ourselves with our own crews. And over time, so that's it, more or less day one. In 2023, and this is it a little bit later. I thought I had a more recent photo of that, but fundamentally, Alan and Kingston Council preferred the trough flow distribution system, I believe modelled on the conventional biosystem in the Edinburgh Gardens in Fitzroy. And this is just another way of getting flow across the surface of the bioretention system. So instead of just having a single inlet, trying to encourage the water to distribute across your system that we often see with the conventional systems, we really trying to maximize the full treatment extent of the system. And you can see in the background here, all this adjacent, all this area is essentially used for landscaping. Looks great. It's a great project, and there's more to come as well. And this, I believe, the water's being treated and then used to irrigate the adjacent sports fields, which is great. Should be more of it. So well done, Alan and Kingston Council and the Ocean Protect guys who were involved in that as well. This one's a bit different. This was installed in 2023. This actually sits on top of a detention tank. So water basically drains through the Filterra system and it discharges directly below it. So there's actually a detention tank, underground detention tank underneath this whole system. And I like this photo because it sort of shows, I guess, the system getting built. So you can see all the different stages of the Filterra bio getting installed. So in this area, the mulch has been placed. This area, the filter media has been put in. You can see the filter media progressively being put in here. This one, just the gravel layer has been put down, and they're doing the bubble ups, etc. So it's amazing how quickly we do these things, but yeah, the guys do a great job basically installing these systems. It's pretty impressive. And obviously over time, the system is just established. We haven't actually brought this system online because the upstream catchment is still undergoing construction. Again, a great advantage of having these systems offline. We can basically ensure that the system's protected from incoming sediment loads that can otherwise damage the system, which we see in conventional systems. This one's hot off the press. This is brand new. This is a really interesting one in Littlehampton in South Australia. It's 120 square meters, and it actually treats stormwater, but also treats recirculated lake water. So there's an adjacent lake as part of the development, and that to help protect lake water quality, the plan is to recirculate lake water twice a week. For about I think 4 or 5 hours each time. So about 8 or 9 hours of pumping every week, basically just keeping the lake turned over, and the water's basically goes through the Filterra bioretention system, again, just to help protect lake water quality. But if it rained, the Filterra system also receives and treats incoming stormwater from the upstream catchment. It's actually modelled on a system we trialled and is still operating on the Gold Coast, installed back in 2018. That was just purely treating recirculated lake water, and it's still going strong. So this is just part of the some fancy footage from the construction. I'm not sure how well this will come off on the webinar, but yeah, you can kind of see what the guys do. So installing the gravel, the under drainage, the bubble ups, the filter media, the plants, and this again is offline whilst the upstream construction activities are still happening. But that's it, more or less day one. And lake hasn't even filled up yet, so interesting, a really cool project. It'll be interesting to see how that evolves in time. Couple of closer to home. These ones are a little bit more closer to my heart. Number one, because I was helped build them, but number two, that I check on them every so often. So these were originally specified as conventional bioretention, so 60 square meter systems, but came to the crunch and the installation, and the contractor realised they couldn't fit them in, so they approached us. And long story short, the Filterra bioretention systems were installed. Obviously, we designed them. These are kind of example design drawings of what we do. Of this system, and this is the install guys just coming through and essentially installing. This is basin number 2, putting in the liner, the gravel, the filter media. That's it, day one. So that's it. What's that? Nearly 5 years ago. So keep that image in your head. This is 5 years ago, and this is it a couple of years later or a few years later, and that's it more or less a couple of weeks ago. So you can see these trees have just really established and grown up. They're really tall. So I don't think I spoke to the guys on site. I don't think anyone's maintained it. They didn't know what it was, and that's cool. It's integrated into the landscaping. Unless you're a nerd like me, you wouldn't know what it is. But yeah, it looks pretty cool, and the plants are growing really well. This is the second system out there. Again, day one, and a few years later. And now 5 years later, the plants are really well established. So again, just give that. So that's it, day one, and a couple of 5 years later, the plants have grown up really nice and tall. So key thing for me is that plants love growing in Filterra bioretention systems. A little bit further up the coast near Bundaberg and Bargara, beautiful part of the world. These will be handed over to Bundaberg Council. So these are three little, and it just gives you, I guess, an indication of the different types of Filterra bioretention systems as well. So three different ones. One's a bigger bioscapes. That's it, day one installation. And that's it, a year later. Again, still offline because the upstream, you can see the upstream construction activities are still happening. And then we've got these two smaller systems as well that have been brought online and are receiving flows. This one, the property owners actually integrated a nice little garden bed adjacent to the Filterra, which is pretty cool. That's the garden bed in the top right there. We didn't plant that one out, but it looks cool. Um, Kepnock, just very close to the Bargara systems. These are just 16 individual systems that are like just little peat systems integrated into a town centre to help protect the water quality from a busy little shopping centre precinct. These are really new. Again, these were installed. This is the biggest ones we've installed to date in Queensland. Two 109, so two systems, 192 and 298. I did the calcs. They were going to be 4.2 times bigger if it had been a conventional bioretention, and they physically just couldn't fit in. So this is it, more or less. This is the first system, basin one. Day one install, so the bubblers and planouts hadn't been cut back, and that's it a little bit later on, and that's it just a couple of weeks ago. And this is getting a lot of flow. They're actually heavily saturating the upstream catchment, so this is getting pretty much a lot more flow than we actually anticipated. But the plants are growing really well. This is the second system. This is just under 300 square meters. So again, day one installation, and more recently activating the system and bringing the system online. Again, diversity of vegetation, shrubs and trees. Pretty much the same planting palette that you'd put in a conventional bioretention system. This one, I reckon, is my favorite. It's a 12 square meter system back at the state high school. So hopefully the kids get a kick out of it. But again, design drawings, so kind of gives you an idea of how it works. So water comes in, hits a little weir, bubble ups distribute the flow. These are little bubble ups. These are the under drainage here, and which drain into a downstream pit. If the water gets too high, they spill over into the overflow pit. And you might see for our bioscape systems, we do put a gully pit basket on these overflow pits just in case, because there's always a concern, like people think, oh, the mulch is going to float. Again, just a reminder, the mulch we use is a double shredded hardwood mulch. So we do prefer, there's a reason why we use that. It has low floatability and low nutrient leaching. But in case for whatever reason, so for some reason it does float, we do put the gully pit basket on the in the overflow pit. But I've looked down a lot of gully pit baskets on overflow pits, and generally like leaf drop from the adjacent plants and not mulch at all. If anything gets caught in there at all. But fundamentally, Oakey, this is Oakey day one, February 2024, and I just checked it out very recently, and that's it, what it looks like more or less now. So day one, a year later, and again, for me, the key message is plants really like, I guess, the Filterra bioretention environment. We generally get asked how big are the biggest. For whatever reason. This gives a summary. I haven't showed the biggest to date. We actually have just installed it in a few months ago in Sydney Metro. So that's our biggest to date. The biggest being 990 square meters, so just under 1,000 square meters. And to the best of my knowledge, it is the biggest in the world. And we've obviously installed a whole bunch of other pretty big ones as well. And literally this month, literally as we speak, we're installing another one just up the road from me in Burpengary in the Moreton Bay region. And I always like showing this photo. So this is Alan West probably recognised this photo as well, because I'm sure I've showed it to him. But this is a system, a Filterra bioretention system in Washington. We can't take credit for this, but I show this for a couple of reasons. Number one, to highlight the fact that this is Filterra bioretention or high flow bioretention is not new technology. It's been in the States for 20 years or so, and 9,000 or so have been installed. And there's a lot of data that shows that they work really well. The other thing I like showing about this is that because these systems are so much smaller, they are easy to integrate. And you can get a bit fancy with the urban design. So genuine water sensitive urban design. So integrating water features or stormwater treatment assets into the urban environment. And for me, a leaf shaped bioretention system is about as cool as bioretention gets, I think. And you can see here, this is another example of the trough or channel flow distribution system. So water comes in here. I'm pretty sure this is actually another pumped system. So water is pumped during storm events and discharged into the channel, and the flows are distributed to, I guess, to help utilize the full extent of the Filterra area. And I'm happy to say, actually, we're going to have another leaf-shaped Filterra bioretention system in the very near future as well in Australia. So watch that space. So a couple of key take-home messages. So again, I am biased, but I really think there's a lot of features that we use in Filterra bioretention systems that do make it better or superior in many ways relative to conventional bioretention. The key selling feature for most people is the fact that it is smaller. So because it's 3 to 5 times smaller, it's easy to integrate. It's also generally shallower. So generally, because of the bubble up arrangement, if we're using that, we can make them essentially a little bit higher. We don't have a transition layer, et cetera. So we generally find that they are a little bit higher. So it's essentially easier to drain, and subsequently there's less of a need for adjacent walls, et cetera. For me, another key thing is, and I feel as though this should be done for all bio and all water sensitive urban design, wetlands, bio, whatever. We do a turnkey approach. So the one group, in this case us, Ocean Protect, do the design, the installation, and as part of any system, we then look after it for a year and take full responsibility for it. If something goes wrong, it's on us to fix it up. And I really think that should be done for all water sensitive urban design assets. I've just stood on the edge of too many bios that don't drain, can't get them handed over, and no one knows why or who to blame or who to pay for it. Third thing is the performance. There's so much data that shows the Filterra and high flow bios work really well. 7 peer-reviewed published studies, SQUID approval, etc., and a lot of work and R&D has been gone into, I guess, proving that they work really well and optimizing their performance. But all these things for me maximize the resilience of these systems. So again, we always have to maintain assets, and we do recommend it. But there's a lot of things that we do for high flow bio that certainly maximizes the resilience. Number one, the filter media, it's super carefully made. It's a 25-step QA/QC process. We don't see anything like that for conventional bioretention media, and we really should. Second thing is the mulch, which again, I feel as though conventional bio should definitely have. Third thing, hydraulic design. Again, having these systems offline, making sure they're not going to be, the flow distribution is really good, and they're not going to be prone to scour and erosion, etc. And the fact that you've got this mulch, it certainly helps to protect the filter media from blocking, etc. Because for me, the key risk for bio is generally the filter media blocking, and it's so easy to just remove the mulch and replace it if need be, as opposed to trying to scrape off layers of the filter media. So thanks, guys. I can see there's a bunch of questions. If you want to find out more, you're welcome to reach out. We're going to do obviously Q&A now. And just a reminder, folks, if you do have any questions, please put them in the Q&A panel. The slides on the recording will be made available on our website. And same again for the CPD forms. If you've requested one already, you're going to receive it probably within a week. But if you don't, just email marketing@oceanprotect.com.au. Cool. So what I might do now, I'm going to stop sharing my screen, and I'm going to dig up the Q&A. Righto. And I might, give me a sec. I might actually bring my screen up because I might actually refer to some of these imagery as well. So bear with me. Thanks for everyone who's put in their questions already. But just a reminder, if you do have them, please put them in the Q&A and not the chat. That makes it just a lot easier for me to manage. So a question from Anoka Sanjiwani. Apologies, I'm sure I mispronounced that. They ask, what is the maintenance requirement for the filter media? Does it require to use Ocean Protect? Great question. Probably the most common question we get. So the maintenance there is no need to ever replace the filter media. So the data, whether it's conventional bio or high flow bio, provided these systems are designed, installed, and appropriately maintained, the bioretention system should essentially last in perpetuity, i.e. forever. I did a whole webinar on that previously called How Long Will My Bioretention Last? If you're keen to find out more, if you email me, I'll send you the link. But yeah, you don't need to ever replace the filter media. Provided it's appropriately designed, installed, and maintained. And that's again why we prefer the turnkey approach, because if we do it, we're a high degree of confidence that it's done properly. You do need, we do recommend replacing the mulch though, but it doesn't, after the system's installed and handed over, etc., there is no need to ever need Ocean Protect to provide any, fancy maintenance service. It can literally be done by any suitably qualified individual or group. Hopefully I answer your question, Anoka. Um, Question from Mosan Mehdi. Welcome. Mosan says, I'm currently residing in New Zealand and attending your webinars. I have requested CPD certificates, blah, 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 blah. Oh, sorry, just after a CPD. Again, Mosan, if you can please email marketing@oceanprotect.com.au, that'd be great. And if you don't have any luck, just give me a shout. I know we've got a bit of a backlog of CPD, particularly a lot of people are asking for CPD forms from like 2 or 3 years ago, which is difficult for us to dig up. We will, but it does take time. So apologies in advance if you're waiting longer than you would have liked. And keep in mind, we get like 400 or 500 people tuning into these webinars, so we get a lot of CPD requests. So if you are waiting, apologies in advance. We are trying to get through them as quick as we can. Anoka also asks, what is the approximate size of the bioretention system per hectare of catchment? Yeah, great question. As a rule of thumb, the Filterra bioretention systems are sized at 0.03. Sorry, I'll start again. The Filterra filter area is sized at 0.3% of the upstream catchment. Now, that's the recommended minimum size, but it's also generally the standard or typical size to meet local stormwater pollutant load reduction targets. So generally find a system size at 0.3% achieves the local targets, whether they be 80, 60, 45 or similar. Joshua Poiner asks, I understand the mulch is replaced ideally every 12 months, but does the Filterra product need to be replaced? And if so, how often? Same answer before, Josh. Yeah, so we should never need to ever replace the Filterra filter media. Again, provided it's appropriately designed, installed, and maintained. Hopefully that answers your question. Another question, same question from Shin Lee. What is the longevity of the filter media? Just refer to my, how often does it need to be replaced? Again, refer to my previous answer. Also regarding plants with high flow media, does it retain enough water to keep plants watered? Look, Shin Lee, yeah, that's probably the main concern I think we've had from people before we actually started seeing these systems in the ground and basically thriving. So long story short, hell to the no. There is whilst the Filterra system does drain really well, it's also really good at retaining moisture within the filter media. And there's two key reasons for that. Number one, we use the mulch layer, and number two, there are organics in the filter media and other properties that help retain moisture within the filter media. Obviously, we do use a planting pallet that does prefer dry-ish conditions, but it's certainly enough water retention in the filter media to keep the plants very happily surviving. Sean Quilty, legend of the Quilty Engineering Hub and esteemed TAFE lecturer. Jesus, I feel like I'm your biggest fan, Sean, but maybe I am. Greetings, Sean. Sean says, great to see Bundy Council taking on proprietary assets. Are there any fact sheets available to pass on to other councils? I think, Sean, if you ever need info on this, just email me. But for me, the key thing is that review paper that was on our website, the one I referred to earlier. That has all the information I reckon anyone would need to know about Filterra, including answers to a whole bunch of frequently asked questions. Question from Simon Blackwell. Any projects in WA? Not yet, Simon, but if you are in WA, give us a shout. We'll certainly consider it. I think the furthest west we've gone is Adelaide, just for the time being. But give us a few years. Who knows? Yeah. Hamed Tabakoli asks, can you explain what the functionality of the steel channels on top of the bioswales is? Yeah, I might go back to that where is it? My little US Washington system. So this, how these essentially work, basically is we want to distribute flow across the entire surface of the filter media. So if I had most conventional bios just have a single inlet, and there's this sort of hope that water just magically dissipates across the entire surface. And I think that's a real misplaced hope. How we maximize the flow distribution of water in Filterra or high flow bio is either bubble ups, which I'll show you a whole bunch of examples of before, or this trough arrangement. And basically, we're trying to get water to spread across the entire surface. So water will come into this main channel, and then you can see these little cutouts here. They're basically little slots or gaps in that on the sides of the channel. That means water can physically just get out and then go along the length of the channel and come to the end and just basically dissipate. So that's essentially what they're doing. So it's basically a flow distribution system. The main flows will go along the channel, but every so often there's a cutout in the channel, and these other channels basically spread the flows further. You can also see little cutouts in the main channel as well, where we're looking to get water out as well. Hopefully that answers your question. Robert Nutt, Robert asks, do you have any examples used in agricultural areas or around waste facilities, green waste? No, I can't show. I haven't got any I can show you. Not for we haven't done any for agricultural areas, but for waste facilities, including I'm trying to think, it's like a composting facility. We are designing one, and I'm not sure if it's being installed anytime soon, but that is happening in New South Wales. I can provide further information if you'd like to know more about that one, Robert. But yeah, it's more or less the same thing. Obviously we're careful about too much pollutant loads going into these systems and pre-treatments, etc. Yeah, we long story short, we'll hopefully have a waste facility system fairly soon. There's probably other ones that I don't know about as well, but generally for any Filterra system, at least over the last few years, I've personally reviewed the design drawings, so I can't think of any off the top of my head. Anonymous attendee, mystery person says, stupid question. Why do you need to seal the bottom of the system? Why not let water infiltrate the soil below? Great. Yeah, so generally we don't have a liner, an impermeable liner. Generally, we let the water seep into the surrounding or the subsoil below, because we do, ideally want to maximize infiltration into the surrounding soil profile. It's not just, again, as I'm sure you know, it's not just about water quality. We're trying to mimic catchment hydrology, and a good way of doing that is to maximize infiltration. And yeah, I'd say for our earlier systems, we did more of the sealed bottom, but for more recent systems, I'd say 90% of them have a unsealed base to maximize that exfiltration. Obviously, sometimes you still want to have a sealed base, because if there's groundwater or whatever, we might need to seal it appropriately. Jagdeep Singh asks, if this system is used inline, what is the maximum flow rate supported by the system? Yeah, it's off the top of my head, it's about 1.4 liters per second per square meter. I'm pretty confident about that one. So it's roughly about, if you've got, it's the saturated hydraulic conductivity, so the drainage rate at the surface of the filter media is 3.5 meters an hour. If you take our standard storage depth, it gets up to, like, as in the maximum flow rate is 4.5 meters an hour or thereabouts. Okay, I'm getting quizzed now, all these numbers. But yeah, great question. Aline Camargo Sena asks, if high flow is bypassing the system, why the system name is bioretention for high flow? No, just to clarify, it's not bioretention for high flow, it's high flow bioretention. So it's called high flow bioretention because the water flows through the filter media, or can flow through the filter media at a higher flow rate. Not 200 millimeters an hour like for Sandy Lane, but 3.5 to 4.5 meters an hour. Yeah, but yeah, the high flows generally are bypassing the system. Yeah, another question from Anoka asks, does Ocean Protect got any product that removes hydrocarbons? Yeah, we ask developers to control it to a 5 parts per million. Yeah, I get asked this, I'd say every second day. Long story short, yeah, I generally am asked as an RPEQ to provide certification around this compliance with this 5 parts per million hydrocarbon target. But in summary, you can always just ask me for a letter or advice on this one separate because there's a bit to it. But the long story short is the vast majority of hydrocarbon is attached to soil. And if you can remove soil, you go a long way to reducing hydrocarbon concentrations. But also the hydrocarbon concentrations in typical stormwater are actually generally quite low. In fact, often lower than 5 parts per million. So, but if you can find out more about that, yeah, just give us a shout. But yeah, all our devices, because they remove solids, they certainly remove hydrocarbons. And a lot of our study data has hydrocarbon data to back that up as well. A question, another one from an anonymous attendee. I note the documentation outlines or indicates a 530 mm thick layer of filter media is the steadfast rule. What is the maximum that could be utilized? Obviously dependent on getting the right treatment outcomes. Yeah, this is something we're not flexible on at all currently. So if I just backtrack a little bit, if you're wondering what we're talking about, if I showed this figure right at the start, where is it? This one. The questions are in relation to the depth of the filter media. So the filter media being this section here. So for Filterra bioretention systems, that depth of filter media is 530 mm. That is the minimum and the maximum. There is no variability, at least for the time being in Australia. We generally find that is the sweet spot in terms of optimizing performance, reducing costs, etc. And all our performance monitoring data is associated with the 530 mm depth of filter media. So that is the golden depth. So clearly it's deep enough to sustain big trees and still deep enough to achieve really good rates of pollution removal as well. Question from Jude. Jude, why Jude? I'll just say Jude W. Jude asks, does bioretention system slow down runoff, reducing peak flows to downstream catchments? Absolutely, it does. Yeah, absolutely it does. So yeah, we see this in our flow monitoring data, and not just Filterra, but conventional bioretention systems as well. They definitely slow down flow. They also can retain a fair bit of water as well. So I'm getting buzzed on Teams as we speak. No rest for the wicked. A question from Hamid Tabakoli. Is the only proprietary product the filter media, or are the pits proprietary as well? No, you can get your pits from anywhere. But yeah, the only proprietary component of Filterra bioretention systems is the filter media. And again, you should never have to replace that. So after we've handed it over and activated, again, we do that always at least a minimum 12-month period after installation. You should never need us ever again. Having said that, you'll probably see my buffhead every so often taking photos of it and checking it out, even after many, many years, clearly. Yeah, Felix asks a question from Felix Goff, and this is probably the secret herbs and spices recipe. What allows the Filterra media to have such a high hydraulic conductivity? I guess the long and short answer is that there's a very, very careful process in actually sourcing and the ingredients in the Filterra media, and they're locally available. I can't tell you what's in them. But they're locally available. It's a very stringent QA/QC process in terms of the sources of materials, the types of materials, and also how we blend it. There's just nothing like it that I see in the sort of conventional bioretention mix that is done to such a high standard, and that sort of I guess proprietary, for want of a better word, or the R&D that's gone into it, ensures the system can drain at a really high rate, but also achieve really high rates of pollution removal, but also support plant growth as well. There's a further explanation in Appendix A of the review paper if you're keen to find out more as well, Felix. So, but again, if you want to know more, just reach out if I haven't answered your question appropriately. Another question from anonymous attendee. They ask, if there is bypassing channel for high flow, isn't the system meant to treat high flow? Yeah, again, might have been a misinterpretation of the term high flow bioretention. No, it's treating small frequent flow events or flow events up to the capacity of the system. We want to bypass the high flows. It's called a high flow bioretention system because the water flowing through that is flowing at a higher rate. Murray Powell, the Mr. Stormwater, Mr. GPT, Mr. Yellow Jacket, Mr. Fish Shirts, welcome. Murray asked the question. He says, what are the key differences between Filterra and I think you mean P-sorb media, Murray. There's a lot of differences. Gee whiz, where do I start? But fundamentally, we don't grow plants in P-sorb media, Murray. But yeah, some fundamental differences in terms of the source materials, the blending, etc. And I guess obviously with the P-sorb medium, that has a limited capacity to absorb pollution, and we generally replace the cartridges every 2 to 3 years, as you know. Whereas for Filterra, we don't have to replace the filter media at all. Again, provided it's appropriately maintained, which I'm sure you're a big fan of, appropriate maintenance. Um, I'm amazed it took this long to get this question. Roshan Kanal asked this question. Could you give some indication or could you give some sense of cost comparing or cost comparison of installing Filterra bioretention systems with conventional to achieve the same objectives? Great question. Might be easier if I look at a picture. So, as an example, if I just look at Silverdale, might be the easiest one to visually look at. Here we go. Okay, so Silverdale. This is so systems ballpark figures, and it does vary from location to location. But I'm being put on the spot, so I've got to answer it. So systems that are more than 100 square meters or thereabouts, we're generally looking at about $1,250 a square meter for the design, installation, and the first year or so of maintenance. So 1,250 square meters, sorry, $1,250 a square meter. Now, the ballpark estimates I get around conventional bioretention systems really vary. They're generally somewhere between $500 to $1,000 a square meter. Generally doesn't include the first year of maintenance, but that aside, we're roughly $1,250 a square meter. Conventional bio is 500 to 1,000, thereabouts. I'm sure someone will say it's different, but that's just ballpark. So per square meter, we are more expensive generally. But the key cost saving is the fact that we're 3 to 5 times smaller. So whilst we might be more expensive per unit area, we're generally cheaper in terms of installation. And that's just purely looking at the Filterra bioretention system. Generally with the Filterra, because we're smaller or easier to integrate, we don't need the deeper, more expensive retaining walls. And obviously, I generally gain back space. So in this case for Silverdale, meant we didn't have to knock down a whole bunch of trees. But for a lot of our projects, we're finding the developers getting back another lot or two. So even though the Filterra bioretention system is generally cheaper, we don't include any sort of cost savings for the developer or council. But keep in mind that number, there's exclusions. So generally, as per the Bells Creek example I showed you before, I might even just bring it up just so you know what we kind of do in case you missed it. Where is it? I'm just trying to find it. Give me a sec. Bells. Oh, I can't find it. So to give you an example, where is it? Here we go. So this is kind of where we step in. So our cost of $1,250 a square meter doesn't include excavation or any sort of external infrastructure like pits or upstream pipes, etc. If there's a wall or like a structural retaining wall, that doesn't include us. We basically do everything within the perimeter of the filter media. So that's generally our where we sort of start and finish. So everything within the boundary of the Filterra, it's roughly for systems smaller than bigger than 100 square meters. It's generally about $1,250 a square meter. For smaller systems, the costs do increase per unit area. But again, if you're keen to get a price, just reach out. And what I'm generally doing most days is that as part of any sort of design, we do provide a cost estimate, and I also provide a cost estimate of the conventional bio option as well, which I can model quite easily as well, and do a cost assessment of, again, based on some approximate numbers. Another question about longevity. What is the typical design life of the system? Noted the use of timber sleepers to divide the walls, which would need more placement more frequently. Yeah, these timber sleepers, that, in fact, we rarely don't, we actually don't use them that often anymore. They're really just a sort of nominal sort of boundary, generally to help with the construction. So we're not relying on the timber sleepers sort of to last forever at all. In terms of the design life of the system, yeah, it's generally what the advice is, and this is based on bioretention monitoring of systems that are 7 years old now. The systems are generally getting better with age. There's data that's come out of the States of systems that are 13, 14 years old. There's no deterioration of performance. So long story short, we're confident that the design life of these systems should be essentially in perpetuity, again, provided they're appropriately designed, installed, and maintained. Keen Lau asks, if the bioretention gets overgrown, this can impact on the accessibility to replace the mulch and the Filterra media. Yes, true. How is the resilience and effectiveness of these systems to be maintained for the asset's life? Yeah, yeah, if the vegetation gets overgrown, for sure, it'll limit accessibility. But if you obviously, you can just obviously trim the vegetation back. But again, we're generally finding we even with really high densities of, sorry, even with visually seemingly high density of plants, like one plant per 4 square meters, you can still get in and replace that mulch as required. Hopefully that answers your question. Oh, sorry, Murray wasn't asking about the difference between Filterra and Peace Orb. He's just corrected himself. Typo. He meant Forb media. The key difference is the hydraulic conductivity, Murray. So yeah, Filterra is draining at 3.5 to 4.5 meters. The Forb media recommends 200 millimeters an hour or thereabouts, 100 to 200 millimeters an hour. So ours is fundamentally different. The Forb media, which has been it's been a little bit out of date now, at least in Queensland, the Forb media used to specify a maximum organic matter content of 3%, so generally less than 3%. And I think everyone's realised now that was probably a mistake because we're getting a lot of systems that are just pure sand and they don't support plants. So ours definitely has appropriate organic matter content and certainly higher than what we'd recommend, than what Ford would recommend. So they're probably the two key differences. Joshua Pointer asks, looking at this exact issue of having a smaller system required for our project, just wondering if you have used Filterra filter media in Mount Barker, South Australia. Yeah, that project that I showed before, Joshua, is in Mount Barker, Littlehampton, I believe. Correct me if I'm wrong. So that asset will be handed over to council as well. And I personally was in a meeting with Mount Barker Council not too long ago and telling them all about Filterra. It was real interesting. That council, I think it was the same council, they're actually recommending conventional bio be swapped out, as in if it's approved or proposed for conventional bio, their recommendation is to use Filterra bioretention instead because of the easier maintenance. And probably because they probably had too many bad experiences with conventional bio. But yeah, they saw Filterra bio as basically being an easier system to maintain by their own crews. So if to the best of my knowledge, unless it's changed, they have a very strong preference for conventional bio. But yeah, if you're keen to check out the Littlehampton system, I know my colleague in South Australia, Rob Denise, loves taking people out to show people around. But look, that's it for quick question and answers. Just a reminder, folks, if you are keen to, badger me for more info or hard questions around Filterra or anything else Stormwater related, please reach out. And just a reminder as well, we've still got 5 or 6 more webinar series in the fundamental series. So obviously we've knocked out number 7 today, but if you're keen to register for the subsequent ones, please jump on the Ocean Protect website. The next one will be by Ian Adams from Organic Engineering, talking about IWM for buildings. Cool. And we've finished ahead of time. I'm stoked about that. Thank you so much for everyone who's dialed in. Much appreciated. Hopefully you guys got something about it. So if you're keen to find out more or just reach out or whatever, just give us a shout and we'll hopefully see you guys in person sometime soon. And all the best for your day. Thanks, guys.